Hi guys, welcome back. So today I will be teaching you guys how to interpret this kind of circuit. Yeah, you know what type of circuit is this? I believe you all know because I have put this as my main title. Yeah, it's parallel circuit. Yeah, I don't want to hide anything from you all. So yeah, it's a parallel circuit. So the black one represents the question and the red one represent the step that I will write later. Yeah. So how to interpret this circuit? Yeah. So before that, if you watch my previous video, I've been teaching you guys how to differentiate the series and the parallel. Yeah, just want to have a quick recap. So the series is when the resistor is 1 2 1 2, and the parallel is when the resistor is 1 2 1 2. When parallel happens when the head to head have a common number. Yeah, and the tail and tail have the common number too. In the series is when the tail is connected to the head of another resistor, so it's 2 1. Parallel is 1 1 2 2. Series is 1 2 1 2. Yeah. So if you still don't understand, you may go back to my previous video, rewatch again. Or for those who are new, haven't watched, I recommend you all to go back to my previous video to learn how I do it for the series and parallel. Yeah, I'm just promoting my video. Okay, let's start. So assume that the current in from here. Yeah, so the current will speed at this node. Yeah, will speed at this node. When speed, so the head will be 1, here will be 1, and here will be 1. Yeah, so definitely the tail will be 2 and 2. The current go back here. Yeah, so as you can see, all the resistors are connected in this node, A node, and N with B node. Yeah, so this proves that this is these three are in parallel. These three resistors R1, R2, and R3 are in parallel because you see they have common number 1 1 1 1 are connected to one node, and then 2 2 2 are connected to the another node, so they are parallel. Yeah, so just very tidy. Oops. Okay, so let's go into the questions. Determine the unknown resistors given the fact that R2 is equal to 5R1 and R3 is equal to 0.5 R1. So yeah, we have known that this overall circuit is parallel circuit, and given that RT is equal to 20 ohm, so how can we do it? Yeah, we can solve this by using the parallel formula. So 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we just put all the value in. 1 over RT is equal to 20 ohms, equal to 1 over R1. R1 is not stated, and plus 1 over R2 is equal to 5R1 plus 1 over R3. R3 is equal to 0.5 R1. So by calculating it, we continue. So 1 over 20 ohm is equal to make it easier, I take R1 out, 1 over R1 out. So this one is bracket to 1 plus 1 plus 1 over 5 plus 1 over 0.5. Yeah, this is kind of factorization. Yeah, so I just take out all the common variable. So in this case is 1 over R1. Yeah, so the next step will be 1 over 20 ohms equal to 1 over R1. Using the calculator, 1 plus 1 over 5 plus 1 over 0.5 equal to 16 over 5. Yeah, 1 over 20 ohms equal to 16 over 5 R1. So I just use the cross multiplications. 5 R1 is equal to 16 times 20, 120. So R1 is equal to 64 ohm. Yeah. Okay. So now we have R1, the value of R1. How to find R2 and R3? So R2 is equal to 5 R1. So we just substitute in the value of R1. So R2 is equal to 320 ohms. What about R3? R3 is equal to 0.5 R1, which is equal to half of R1. So how to find 0.5? And just substitute in the value of R1, and then it's equal to R3 is equal to 32 ohms. Yeah, this is how I interpret this circuit. Yeah, so thank you for watching. See you next time.